Okay, so in this video, we're going to be talking about a new property. It's known as the intermediate value property, right? So before diving into the property, let's just talk about a few examples and see what the issue is and how we can link these two examples to the extreme value property. Right, so if you have a function, p of x, and that equals x to the power 5 plus x to the power 3 plus x plus 1 plus 1, then we're going to try to find the root of this equation, right? We know that this function p maps all real numbers to all real numbers, right? So let's just try to find a solution by trial and error, right? You guys might have encountered this method before. Let's try to plug in a -1 and see what happens. Well, -1 to the power 5 plus -1 to the power 3 plus -1 plus 1. If we just rewrite this, we get plus 1, we get a -2, right? That didn't work. We want it to be equal to 0 for this to intersect the x-axis, right? That's basically known as a 0. It's when that's basically when y equals 0 and the x-axis is intersected, right, by a particular function, p in this case. So let's just try p equals 1, right? That's going to give me 1 to the power 5 plus 1 cubed plus 1 plus 1, and that's turning out to be 4. So if you were to think about it logically, between these two values, -1 and 1, would you guys expect a 0? And would it make sense to expect a 0? I mean, if you think about it for a second. Well, logically speaking, it wouldn't make sense, maybe. But if you think about it, it's jumping between -1 and 1, between this interval. We can observe a jump from 0 to 1, basically. And if we can figure that out, if we can figure out why that is, then maybe we can try to understand whether a solution exists in the given interval. See, the point of all this is to not find the solution, but actually determine if a solution lies in this particular domain. Actually, we should rewrite this as -1 and 1, not as -1 and 1 in round brackets. So, as you can see, the idea is that there's a jump from -2 to 4. So regardless of what the graph looks like, there's a value of x for which there's a negative value here, and this is -1, right, in this case. And at +1, there seems to be a jump. So somewhere along the way, regardless of what that pathway is, there has to be a change from the negative to the positive y value, which means there has to be a point on the graph where x has been intersected. Basically, the x-axis has been intersected. So that was the whole point of this example. And it's not important as to what the solution is, but the idea is that the intermediate value property kind of talks about this, and we're going to write a formal way of a formal definition of the intermediate value property that's going to help us determine whether the x-axis is intersected in any particular case between any two particular values or a closed interval in which this example can be related. Okay, let's consider another example. Let's consider a step function that goes from all real to real numbers, right? Then f of x can be rewritten as, basically we retain the value of -1 when x is less than or equal to 0, and a value of +1 when x is greater than 0. Okay, so these are two particular cases in which this happens. And if we were to visualize this using a graph, we'd understand that for all negative values, including 0 and up to 0, there is a value of -1 here. And then at 0, basically not at 0, at 0.000, a very small number that's very close to 0, there is a jump to +1, right? But at this point, it's just going to carry on. So for this particular case over here, we are going to end up with a hole. Why? Because if you try to visualize this, we can observe that this point is not being satisfied by this line. So what happens is this point lies over here, and the sudden jump goes to this place. So thinking about it, it's not really a hole over here. It's just discontinuity of some sort. If you think about it, the graph is not exactly continuous at this point, but that's a different argument that we might consider later on. What's important to take away from this explanation is that there's a jump from -1 to +1. So let's just write that down. So for f of basically the number in this case would turn out to be -1. For this we have a -1 value of f, and for a positive one we end up having a value of 1, right? But that's just our intuition. We could have any value over here, but the whole point was to link the intermediate value property to this. So the intermediate value property can now be explained in a more formal way. So basically we would have a function in this case, and it would be a continuous function, right? And we are assuming that f is a continuous function, and it's continuous at every point that lies between a and b in this particular domain, right? And if that is the case, if it is continuous throughout a and b, then f attains every value, according to this, between f of a and f of b. So basically, if the first condition holds true, then the resulting value of y, the resulting value of the function f of a and f of b, would be exactly this. But the whole idea is that for this condition to be applicable, this function has to be a continuous function, and it has to be continuous in that particular mentioned domain. So basically, let's try to apply that to the example we tried to attempt in the first part, right? So we have a polynomial p of x, and it's basically x to the power 5 plus x cubed plus x plus 1, right? We know that the interval in this particular case doesn't really matter, so we're going to use trial and error to find the interval, and that could be the case for most polynomials. So we would have to use trial and error to find where the sign is changing, right? So p of -1, as we calculated in the previous part, gave us a -2, and p of +1 gave us a 4. So at this point, what we can basically say is that polynomials are continuous everywhere on the real line, and we've talked about that multiple times, right? And they're continuous on -1 and +1 as we can see in this example, right? As illustrated in this particular case. So if they're continuous everywhere, they're continuous here as well, right? And if that is the case, we can use the intermediate value property right now and say that p attains every value between -2 and 4 on the interval -1 and 1. So since all the conditions are satisfied for the IVP to be applicable, the function p would occupy every value between p of -1 and p of +1, simply because the intermediate value property is applied over here. So using all of that, we can say that yes, p would attain a value of 0 in this interval, which basically suggests that it intersects the x-axis. So that was like a more formal way of expressing why there is a sign change rule, and if there is a sign change rule, where the intersection lies. So in the next video, we're going to do one more example regarding the intermediate value property, so we can wrap this section up that talked about two theorems that are very important in calculus. See you guys in the next video.